Greetings dear students, welcome to this tutorial video. In this video we will discuss how to create daemon threads using executors. The method is similar to naming executor threads that we had discussed in the previous section. We have to implement the thread factory interface and write code to make the threads run as daemons there. Without further ado, let us do it. I have a skeleton class here by the name of daemon threads using executors. We can use the same task here as we had used in the previous tutorial for creating daemon threads using the threads API, that is loop task D. But we still need an implementation of thread factory for this example. So I am going to create a new class called daemon threads factory. I would also like my threads to be named. So let us make daemon threads factory class extend the named threads factory class that we had created earlier while naming the executor threads in a prior section. Now we need to override the new thread method here again. As we need the threads to be named, we need to call the superclass's new thread method first. Now I am thinking of making every alternate thread as daemon here instead of all the threads. So let's do that. Now that completes our daemon threads factory. Back to the daemon threads using executors class. Let us use the daemon threads factory in the daemon threads using executors class now. I am now going to submit 4 tasks to this executor service. I have set the sleep time for tasks 2 and 4 to be more here than 1 and 3, thereby making the tasks 2 and 4 run longer. The way we have coded daemon threads factory, the even number threads will be made daemon by it. So tasks 2 and 4 are going to run in daemon threads. Let us run this class now. We see that as expected, threads 1 and 3 are user threads, whereas threads 2 and 4 are daemon threads. As we had set the sleep times of threads 1 and 3 lower than 2 and 4, they have run quite fast and finished. We also see that after the user threads 1 and 3 have finished, the program has ended abruptly, killing the daemon threads also along with it, which is as expected. Now let us modify the sleep times of the tasks a little. We are going to make the tasks run successively longer as per their sequence number. So let us run this updated program now. Again, we see that threads 1 and 3 are user threads, whereas 2 and 4 are daemon threads. Task 1 finishes first, and then task 2, and then task 3. As task 3 was the last user thread running, as soon as it finishes, the thread running task 4 is automatically terminated by the JVM, which was a daemon thread. And then the JVM also terminates, thereby stopping the program. Task 2 was also running in a daemon thread. As we had made task 2 run faster than task 3 by setting its sleep time to be lower, it completed successfully before task 3. So there was no need for the JVM to kill it, as it had already terminated. That's all about the daemon threads. Hope you enjoyed this little tutorial. See you in the next section now, where we will discuss how to check if a thread is alive using the Threads API and also the Executors API. Bye bye.